Joining the weekly collaborative analytics workstream meeting. We have a pretty packed agenda today. This meeting is being recorded. I'm going to turn it over to Justin, who's going to start with some high-level updates.
Hi, everyone. Welcome again to the weekly collaborative analytics call. We'll start with a number of brief updates, then have a discussion around tool integration, discussion of the ongoing work for developing consortium papers, updates from clinical scenarios and data analytics group, and our main presentation today will be from Randy Foraker at Washington University, who will be talking about the synthetic data workstream and give us a demo of the MD Clone product. So just a quick update on some key stats. We've had 72 DTAs sent, 37 executed, 13 IRB protocols approved, 11 that have gone through both DTA and IRB approval, 23 gate sites that are now working with Emily and her team in getting the phenotyping process developed and integrated their sites, and 4 sites that have transferred data successfully. So hopefully this is a now familiar depiction of the architecture of the N3C, comprised of 5 work streams. Today, of course, is the collaborative analytics call, which has 4 subgroups. I just want to point out the URL here, and Usman, if you can please actually put the link to this presentation so that everyone has access to it. We've made some updates to our onboarding process. So even if you've already gone through it, as I have, you can edit your response, click here, and it's important that you put it as your primary email address, your institutional address, as this will be important for being able to access the N3C enclave. And then you can go through the rest of the process where we have information that we're hoping to collect. We now have a required ORCA ID field, which is important for the publications that we'll discuss shortly, institutional URL, clinicians we were hoping to acquire their therapeutic area of interest, and then of course all the URLs to be able to access the different work streams, calendars, and the subgroups that are shown here. So again, if you've gone through the onboarding process, you can go back and update the information and also be able to join different work streams and subgroups through this mechanism. Okay. So some updates for access and training to the N3C enclave. I think many of you have likely received an email over the last couple of days, perhaps today, which would provide you access to the data enclave. And of course, this is just access to the platform. This is not access to the data itself. The DUA and data access committee is required to be able to access either the de-identified safe harbor data or the limited data set access. And again, this is access to row level information for exploration and modeling. Ken, if you can perhaps give us an update on the DUA.
Yeah, the DUA went out to the NCATS team, sent a blue line to Christine, and she and John Wilbanks are getting us some feedback from the community. We hope to have all that feedback and placed into the data use agreement and have that sent off to the NIH Office of Director, and hopefully we'll get approval for them right away. We have given them the Office of Director initial copy of it, and there were very few comments, so we're hoping that anything that comes in will be minor, and hopefully this will be out either probably the beginning. Our goal was this Friday, but it's still this Friday or sometime the beginning of next week, so we're still on track. Great,
Ken. That's obviously very exciting. This is once we have that in place and institutions can sign, then we'll effectively be open for business. So thank you. A quick note as well about the training. So we do have some here on this slide. It shows how people can access this once they have access to the system. They're invited to join WebEx calls that are happen on a weekly basis. You can use these links to register, and this is general Palantir training. This is not necessarily specific to N3C, but it should give those who are new to this environment some understanding of the fundamentals of the platform. And I know that the Palantir team has been hard at work at making some of the material within the platform more readily available and organized. Nabil, do you want to comment on that? I can show the screen if you'd like.
Yeah, do you mind if I switch to my screen?
Sure.
Cool. As I understand it, I think Raphael should have sent out the logins to people on this call today. If I just let Justin and the team know, and we'll be able to get you on. Can everyone see the homepage here? Justin, is that visible?
Yep.
Okay, perfect. So when you log in, we've put some very basic instructions here to get started, and the one I want to draw everyone's attention to is the number 1 here. So in lieu of a kind of scheduled training, although we'll be offering those too, if you click the question mark on the bottom left of your screen and then click this Academy button at the top of the menu, it's actually super nice. So there's a tutorial for kind of every aspect of or most aspects of the platform, including kind of the Python and R coding, et cetera, and it's interactive. So it essentially walks you through all the fundamentals of how to navigate and how to find stuff. And then if you get stuck at any point, there's kind of hints that you can use as well. So as an example, it asks you to expand and collapse the left sidebar. And then if you can't find it, you click that light bulb and it tells you where you should be clicking in purple. So this is kind of a really nice, easy way. And there's a bunch of sample data in the platform while we work on getting your real data that you can use to just kind of get familiar with this as we start.
Thanks. And I do know this, the SynPuff data is loaded in that environment, which is, I think, the closest thing we have to the data that people will be using to model. So are there links to that, to where that data set is, Nabil, within the training?
Yeah, we can add those there.
Okay, great. This might be actually a good time. We've had a few questions as emails have gone out. People have begun to onboard. This might be a good time to address some of those questions. Do you have, Raphael, does Nabil have a list of those questions? No, okay. Raphael, are you talking?
I am now, sorry, I was on mute. So one of the common questions we are getting frequently from a variety of individuals is related to 403 errors. So this goes to Nabil and everyone else. If a user is experiencing a 403 error, who can they reach out to get that troubleshooted, or are there steps they can use right now to hopefully resolve some of those errors?
Yeah, so in the email, I believe there was 2 email addresses included, one for NCATS and one for Palantir. So if you email those, you will get a response. I've responded to a few people today already.
Great.
Typically, the reason for it is that the email that's whitelisted doesn't quite match your institutional email for some reason. I know there's a lot of variants that everyone has. So usually it's just a mismatch of that kind.
So this is Melissa. I can speak to that. So originally when we made the onboarding form, we said your preferred email, not your single sign-on email, as the primary email. So a lot of people are going to have that problem. And I need to have a little think about that, because people don't want to always use their institutional email as their primary email. So we're going to have to fix the onboarding form to address that issue, I think.
Yeah, one thing we've done there, Melissa, is we can whitelist multiple email addresses for a given person. In your case, I know you're part of like 5 different institutions, so we can do that, just as an FYI.
Okay, great.
All right. Thanks, Nabil. So now I'm going to turn over to Hongfang, who is leading the NLP work group as part of collaborative analytics. This was recently launched, and I just want to have the opportunity to engage those who are interested in this. So she's just going to give a quick reminder of what this working group is trying to do. Hong Fong?
Great. Thanks. I listed some of, this is the new subgroup in N3C. I know we're currently trying to look for people to participate, but at the same time, while reading through all the work streams, we need truly to see how this N3C NLP subgroup fit with all the other different work streams, including phenotype, ETL, data harmonization, because it seems to be touch a lot of the different data work streams. So this is the things we were thinking as this subgroup, what do we want to achieve in the goal perspective. So first we want to see for the different data, different size, how can we enable the generation augmentation of the N3C data sets in common data models with information extracted from the clinical narratives. This to us is quite important because a lot of clinical scenarios, use cases will tap into information that may not be completely coded. And the level of codification across different sites can be quite different. When we deal with the overall data quality check, we probably will notice those gaps. And how do we encourage different sites to augment the data with information extracted from clinical nodes? So that's our short-term goal, which is the kind of immediately relevant to the N3C cohort data sets. There are things we want to try to see is that how can we achieve this through four different processes we needed to be doing. One is for sites, they may not truly have the clinical documents available in their clinical data repository. How can we as a team assist the extraction of clinical documents for those site-specific N3C cohorts? And also store them behind a firewall, which is, what kind of data store we recommend people to use. We also want to try to, for sites with general clinical NLP systems, we recommend how to run it or how to run those N3C concepts, extraction algorithm, which we propose to develop. Including those signs, symptoms, and outcomes. Third is how we, what are the problems information we need to keep and to populate those site-specific N3C data sets for the social NLP-derived clinical concepts. And lastly, how do we return the traceability to facilitate data reproducibility? As we all know, there's the PHI information in the clinical notes. We know some sites, their informatics team may not be able to get access to the clinical documents without the identification process. So how do we enable that, facilitating that while return traceability? We will try to work with the team and figure out how to do this across different CTSA sites. Any question on this short-term goal?
Hong Fang, this is Melissa. I am super excited about this. This is like really just amazing work. So thank you so much for leading this. I am just wondering if you could just say a few words about what kind of structure do you anticipate being able to create for pushing this data into the N3C? And maybe that's not yet determined, but I'm really excited about what sort of model or standard would be used. So basically, for example, if people aren't running your MedTagger tool, but some other process, could they feed into the same structure that from their own text mining pipeline, essentially?
Yeah, so this is probably the next slide have some. We'll try to see, can we see the next one? So how do we creating a community participatory environment through the engagement of the different streams? So we do know that Odyssey have an NLP table, and it's in working. It's currently piloting across multiple different CTSA sites, and also you know, some sites have leveraged that. We want to try to facilitate in the wide adoption of that for the Odyssey, for sites with Odyssey CDMs. For I2B2, we are current sources for those sites with I2B2 or Piconet. Their data model itself does not truly have the NLP component tables to store. So we were thinking to derive those derive those clinical concepts and populating with traceability to be, you know, source information to be noted there. But still need a lot of work and try to get the community to see how to do that, because for Mayo Clinic sites, we do have the a different environment where the common data model MARS is more structured, and all the clinical notes pipeline is a separate pipeline, but separate infrastructure. So we were thinking getting involving different work streams and try to see how we do that. So far, the most tangible things we can do is that populating those existing observations tables with NLP derived concepts, but with the provenance information stored separately. So did I answer your question, or is still it's still a lot of work, I know.
Yes, you did very well, and the summary is it's complicated. But there is.
I can add a little bit more, Melissa. So I think the idea is definitely we should allow any tool developed by different institutes to run on this platform. So we will not limit to the tools. We're more focused on trying to define the output of NLP system. For example, different system, maybe one pipeline is extracting sign symptom, another pipeline is extracting lab test. So if we say all the NLP system, you output the same output format, then those two systems actually can be combined together, even to integrate together to have a combined system to extract both sign symptom and lab test. So that's our plan, is trying to more define the output of NLP system. So they can be, each other can be run together, or you want to be able to compare performance on the platform. Yeah.
That sounds fantastic. That's super exciting, you guys.
Yeah, I mean, this actually reflecting the first activity we will hope to do is I call clinical concept glossary. Basically, what are the crucial COVID-19 related concepts and how you define, how you prioritizing it. This may come from, you know, ontology or standards or specific clinical research, but we needed to develop that glossary, because this is more on the consensus building standards development side, is that you cannot have a site-specific clinical concepts where other sites don't agree with your definition. So this has come to an important part, which is I think we hope we can achieve is a text document connection. What we envision here is a small sample de-identified synthetic patient encounter information for a small number of patients, like 5 patients or 10 patients from your local cohort, and get their encounter level information and de-identify them and generate synthetic kind of reports, which, you know, the meaning of the documents represent, but the actual text may not be, maybe replaced with synonyms or with something which is synthetic. So that's what we hope to do, and we are trying to piloting this first across the OHNLP sites and try to see how we can make a process, generate a process for that and for other sites to contribute. So now the third one is to have a crowdsourcing environment for the N3C baseline NLP algorithm development. And we already have a CD2H cloud instance environment, currently pending approval for the namespace. So that's the 2 short-term goal. If we can achieve in the first year, first 3 to 6 months and or 6 to 12 months, we consider it as a success. The long-term goal, of course, I mean, we think beyond the N3C. If there any way we can leverage this COVID N3C cohort as a use case to establish the NCAT CD2H NLP ecosystem. With the current plan, if we can have a sample into and NLP implementation for all the CTSA sites to adopt for enhancing their site-specific text analytics capability, and also open source, open NCAT CD2H NLP ecosystem through promoting standard adoption best practice and organizing text analytics shared tasks through, for example, dream challenges, and also bring NLP tool developers to the consumers. That's the long-term goal. I think that's all I have for this NLP subgroup, and hopefully we have more people join us for this journey because it's so fascinating when you get into NLP. It become almost everywhere you go, it's become a roadblock, but we hope we remove the roadblock for people through this community effort.
Thank you, Hanfang. The reminder that we have our weekly calls for the NLP group every Thursday at 3 p.m. Eastern time. You can go through the onboarding process to get registered and get the calendar invites for the Zoom meetings. Great,
thank you.
Okay, so we'll turn to a brief discussion around tool integration. I think this has been an ongoing discussion about how to best integrate third-party tools into the Enclave environment. There's certain considerations that we want to share in terms of security, provenance, attribution, and all the other features that come baked into Foundry, and what does this mean when you think about adding third-party tools. And we've so far been really focused on the Odyssey Atlas tool set as a kind of first pilot to think about how to manage tool integration. So I'd like to pass it over to Neil. Is it you or someone else at Palantir to kind of describe the different points of integration?
Will be me today, but I'm sure they'll chime in too.
Okay, great.
Okay, so, I see you've got the slides there already, Justin.
Yep.
Is it actually okay if I share these? Might be easier because I'm going to flip back and forth a couple times.
Okay.
Thank you. Cool, hopefully everyone can see that. Okay, so I was asked by Justin to, oops, sorry. Everyone can see that? Perfect. Yeah, so I was asked to share a little bit about how or what it means to actually integrate a tool into Foundry. So this is a pretty interesting topic, and we have a variety of integrations with a bunch of the customers that we work with, including the NIH, of course. I was intrigued that we were just talking about NLP because at one of the clinical centers we work at, we actually leverage a lot of these integration options for various third-party NLP kind of specialist companies that these clinical centers work with. So it's a really nice example of this exact thing. So I just wanted to kind of go one level deeper today and just explain what it means and what the various options are for integrating tooling. So with that, I'll just kind of run through the options. So number one here is what we call kind of a native integration. So as most of you have, I think, seen, Foundry has a lot of its own concepts that make this a particularly kind of well-suited platform for the mission at CD2H. And with this project, everything that you do in the platform is kind of traceable back to the original artifact that it started out with. So in this way, it kind of preserves attribution and reproducibility in a way that makes it quite suitable for a large group of people collaborating on the same data.
Nabil, can I interrupt you for a second?
Please.
There's a request to make it full screen, please.
Oh, I'm sorry. How's that look? Oh, are you seeing my publisher mode? I'll tell you what, Justin, let me pass it back to you because I think my multi-monitor setup is breaking it.
You only need to swap displays up at the top left when you're in presentation mode.
Okay. Yeah, I'm happy to switch back and forth as needed.
Yeah, cool. Okay, hopefully that's better. All right, and then if you could go to the option 1, Justin, the native, yeah, perfect. So, so this is what we've already done for a few of the Odyssey libraries, and for example, we've done this with the feature extraction library. So what this involves is basically like taking some of the code that lives outside of the platform, and then just kind of moving it in, and there's various ways to do that. We've also done this with a group at Stony Brook last week to power one of the kind of upcoming cohort studies, where we took an existing set of pipelines around using SQL and R, and essentially just ported them into the platform. There are often a couple of minor tweaks required. One of the reasons for this is that as the platform is backed by Spark and HDFS, if you aren't writing things like Spark SQL, then there's a few adaptations to be made there. But the nice thing about this is that it kind of preserves all of the native concepts that the platform has regarding attribution, etc. The downside of this approach, obviously, is that there's some extra work required to be done in order to adapt your tooling into the platform's kind of native concepts. So if you go next slide. All right, so this is the kind of direct API connection option. And so obviously, not Foundry, wherever it's deployed, exists within an ecosystem of tools. And so this is kind of the most popular option for the integration of external tooling, and in particular, where there are front ends that people prefer. So for example, at a lot of places we work, people prefer to use visualization tools that they are familiar with, such as Tableau, Power BI, Spotfire, etc. And so then the question becomes, okay, let's suppose that your organization's hosting some data inside the environment, let's say for security reasons. How can external applications work with that data in a way that's safe and preserves those security and attribution features? And so this diagram essentially shows that option. So we have REST APIs that are available in the platform, and now that everyone has access, you should all have access to the API documentation in there as well. And what that allows you to do is essentially get two things. One is read-write access to the data layer. And so this is the way, for example, that we work with various genomic systems at NIH. So the BioWolf supercomputing cluster is one example, whereby Foundry hosts some of the data. Foundry then kind of triggers a lot of the jobs in these external compute clusters. And then the read-write kind of takes place through these REST APIs. And as the other thing that's worth making clear in this diagram is that you have the kind of AWS GovCloud environment, which is where Foundry is hosted. You then have the NCATS East-West environment, which isn't GovCloud, but which is also based on AWS. And so this just involves those two pieces kind of talking to each other, but the data doesn't actually leave the GovCloud hosted cluster. And then, so Justin, if you go to the next slide, the final option, option 2B that we discussed was essentially setting up a parallel database outside of the GovCloud environment. So this is what this diagram is showing here. And then you establish a kind of sync between the two databases. So on the left side here, you have the Foundry GovCloud environment. On the right side, you have a different environment, in this case, the NCATS East-West environment. And you set up a separate RDBMS in that environment, and then you essentially sync the two kind of clusters. And so this can be done. One nice thing about this is that the data can be synced to whatever frequency you want effectively. The downside of this is that the Foundry platform has obviously undergone a pretty thorough security audit in order to be GovCloud and FedRAMP certified in the first place. And so with sensitive data, such as the data that we're working with here at N3C, it's nice if the data doesn't have to leave that environment. The other piece of it that is the downside is that once you're working on data that's on the right-hand side of this diagram, anything that you do on that data is not actually audited using the native Foundry capabilities. It may be audited in some other way. The upside about this option is that there are many applications which, in order to run, have to have read and write access to on RDBMS. And so I believe Atlas is one of these examples. And so if we want to run tooling such as Atlas in this environment, then we would have to pick one of these options. The option that would preserve the kind of native user experience of applications such as Atlas would be this one. However, there are features that were specifically designed to accommodate the requirements of this use case, such as losing the ability to export data, etc., which would have to be replicated in each of the applications that are set up on the right-hand side of here. So those are the three options that are there for integrating external tooling into Foundry, and I'm happy to answer any questions.
Thanks, Nabil. I know that was getting perhaps low level for some of you, but this is, I think, a fairly sophisticated and technical audience that might appreciate some of this discussion. Regardless of any of these options, we of course won't compromise on the security and the governance model that requires that data is not allowed to leave the system, the data enclave itself. So you know, that'll be obviously consideration in any of these options. Okay, so we're going to have a hard stop in 6 minutes. I want to make sure we give Randy enough time to give her presentation. So let's see how far we can get with the remaining topics. Melissa, do you want to talk about what's happening with our manuscripts?
Yep, absolutely. So the link is there. We can also put it in the chat. In order to access the paper, you of course need to be onboarded. We can put the link to that as well in case there's any newcomers. We welcome consortial authors, and there's a link there to the authorship form. To be an author, you have to contribute to N3C in some way, which can mean that you've been contributing in these calls, or if you and you must have read the paper and contributed any ideas to the paper. We're going to be submitting later this week, so we'd welcome your comments and feedback very quickly. The paper has been an amazing experience in just a week. We've written the paper in a week, and there are around 120 authors already listed in that spreadsheet. So it's been a really neat experience to just have everyone contribute and really make the messaging really by all of us. So we'd welcome you there. The only thing to note is that it's really trying to cover briefly all of the work streams work to date and kind of a marker paper for the regulatory and infrastructure work that has been done to create the N3C. The paper is currently way too long, so if you add anything, you have to take something else away. And so on the erring on the side of having enough time, I'm gonna stop there.
Thanks, Melissa. And Joel, do you want to give an update on the second manuscript that's underway, cohort characterization?
Sure, absolutely, and I'll be really brief as well. So a increasingly large and very energetic group of people are meeting increasingly frequently to put together a paper describing the sort of core statistical characteristics of our population, with the intent of this being finalized probably in about a month, when we have 20, 30 institutions. The exact number is still sort of up for debate, and we've been having some very good discussions about what sorts of population characterization should go into this. And then the next slide. In addition to that, there is there are a variety of efforts that are self-organizing with the incredibly helpful assistance of Andrew and the project managers to take deep dives into various clinical issues, with the ones on the left being coming to life and becoming active with a number of other proposed areas. So it's very exciting, and it's really just coming together now. And so to sign up for task teams, click below, people who are interested in looking at clinical issues.
Great, thanks, Joel. And I think maybe next week we'll take a deeper dive with some of these, so people can appreciate some of the discussion that's happening there. Okay, great. So Randy, I see you're a panelist, so you should be able to speak, and I can run the slides for you, or I can pass it over. What would you prefer?
Wonderful. Thank you, Justin, and thanks everyone for reserving enough time for this demo. I really appreciate it. I am faculty at Washington University School of Medicine in St. Louis, and I direct the Center for Population Health Informatics in the Institute for Informatics. And it's my pleasure to share with you a demo of the MD Clone local instance that we have at Washington University in St. Louis. I supplied these slides today in order to provide you with some background on 3 distinct non-COVID use cases. So I won't have time to go through both the live demo of MD Clone and these slides. So Justin and company, would you prefer that I do the live demo and leave these slides as a backup, or would you rather I go through these slides demonstrating non-COVID use cases?
I think the demo is really compelling to see it live. So
I'd go for the demo, definitely.
Okay, very good. So I will do that. But just to be clear about what the slides contain, they're not COVID related, and they are 3 distinct use cases that we ran MD Clone through, comparing the real data to the synthetic data derivatives. And we selected those 3 use cases based upon the granularity of data that was required. One of them that you will see, we ran a logistic regression with some time of day and weekend variables, just a simple logistic regression to predict injury severity. In use case 2, we developed and tested a model for sepsis on the real data and compared that to a model that was built on synthetic data and tested on real data. And then the 3rd use case was a geospatial analysis where we evaluated rates of sexually transmitted infections by zip code using real data and the synthetic data derivatives. So I think that those use cases, as you go through the slides, will really help you understand what MD Clone is good for in terms of its utility in getting the same answer as real data in the real world. I also wanted to mention before I launch into this live demo is that Adam Wilcox and I are leading the synthetic data validation work group. And what we want to do with that work group is identify use cases similar to the slide deck that I'm sharing with you that I'm not actually presenting on in detail, but that are COVID related. And what he and I are going to do before the data assets are completely ready and ready to mine is we want to go through the pre-work, if you will, of using our local instance of MD Clone, which you see in front of you, as well as limited data sets from both Washington University and the University of Washington to write the code for running these use cases that we identify for COVID. So we're going to do some pre-work, and we invite you all to be part of that as you are interested in being a part of that. We presented this morning to the clinical scenarios and data analytics subgroup, and what we got from them in terms of what they would like to see from these use cases is an increasing complexity of models, so adding more and more variables to see whether the synthetic data derivative deviates from the real data. We also want to design these use cases so that we can identify any weaknesses in using the synthetic data derivatives in this regard. And again, we remain open to your feedback. So with that, I'm going to launch into this particular demo. And what I want to orient you to first is that for using MD-Clone, first you need to define a reference event. And so for this particular reference event, we chose a positive test for COVID-19. And along the right-hand side of the screen, you can see that at the time that these data were loaded into the data lake, there were roughly 2,000 patients with such a diagnosis. When I navigate to the next page, this is where we choose all of the possible variables that we want to use in the model. And so you will see from these tabs up above the proportion of patients who have this particular outcome definition of interest. And we have laboratory values as well as symptoms and comorbidities like diabetes, whether the patient was ventilated or not. And specifically, for example, I'm going to hone in on this ventilation variable. We specify for this particular variable that we want to get the first ventilation event at or after the reference event. So if you remember from the previous screen, that was a COVID positive diagnosis. And then we also want to export the ventilator start date and the ventilator end date. And so these are the details of the variables that you will actually see in this output synthetic data derivative. I will also show you, for example, a comorbidity like diabetes and how this was specified. The nice thing is with MD-Clone, if you're not sure about the black box of what is contained in MD-Clone from a data perspective, you can search for it as a hierarchy variable. And here you'll see that we ultimately selected type 2 diabetes as our comorbidity of interest for this particular data definition. And again, we got the first diagnosis of diabetes, and this was ever. So in case we had seen this patient before in our healthcare system, we would know whether they'd been diagnosed with diabetes or not and have that comorbidity. So here we specified after, in contrast to the ventilation variable where it had to be at or after that reference event of being diagnosed with COVID. And then what did we pull from this particular variable, and what you'll see exported in the synthetic data derivative is whether or not they had the condition of diabetes. And so you go through the same process, building out the variables that you want to see in your synthetic data derivative. And I just gave you a few examples. You can also choose from medication lists. In this case, we chose a statin medication, and we wanted to know if it was administered or not. And we wanted to see if any from this list were present. And as you can see, we chose quite a variety of applicable dosages as well as types of medications that fall into that class. We wanted to know whether they were given it in terms of the last one in this window of time that we specified, whether they were given it ever, and whether the medication was administered. So those are a few examples. And also in terms of patient demographics, you can specify on this page whether the patient had died or not. And again, this death date is not a particular date, like a calendar date. However, it is the number of days from the reference event, which is that positive COVID test. You can also specify that you want to export the patient's ethnicity and their gender in the resulting synthetic data derivative. And I'm going to advance to the next screen. And as I do that, and as I generate the synthetic data derivative, please let me know if you have any questions or if there are any salient questions that have been posted in the chat that I should be responding to.
Could
Could you provide a methodological description of how the synthetic data is actually, because it's not really clear. This might not be the place for it, but I'd love to read about how the tool actually generates the data. For instance,
I'm so
are
glad you
the
would like to read
variables
about that,
independent,
because the
or
manuscript is in its 3rd revision currently, and I hope that it will be published soon. I can certainly give you all access to the preprint, which tells you as much about it as I am allowed to say about it, because it is a commercial product. I can say that the process of the synthetic data generation is algorithm based. And so importantly, it builds a new synthetic cohort based upon the individuals that feed into that cohort in real life. So if there are, for example, too many unique variables in a string for that patient, then that patient won't be able to be created as a synthetic data derivative. But rather, if there are enough patients like that patient, then they can be represented in aggregate in the synthetic data derivative.
just briefly, sorry for interrupting, but why is MD-Clone better than other options? What is special about this program?
I think that probably instead of going into it here, I think it would be good to provide you with that preprint version of the manuscript so that you can evaluate it yourself. What's nice about MD-Clone and what you'll see here is that it generates a synthetic cohort on demand for that particular query. And with each individual query, it will regenerate that synthetic data derivative. So it's based upon which variables you need from the source data itself.
Thanks very much.
Whereas there are other algorithms and programs that aren't quite as flexible in that regard. But I'd be glad to share more information, more detailed information with this group. So let me just show you here the output that is in this flat file that is generated. Each row of this file is a unique patient. And you'll see above on the top row of the table, all of the variables that we requested in that query. And you can also see that these data look and feel like real patients, even though they are synthetic data derivatives and they do not correspond one-to-one with the patients that they represent. Another feature of this particular program is that you can generate a comparison file. And as I'm doing this, I just wanted to make sure, was anyone not able to see the Excel file that I just showed? Sometimes screen share fails me, that's why I'm asking, and I need to reshare. Okay, so now I'm generating the comparison file. And what I want to show you here is the comparison report between the real data and the synthetic data derivative. And what you can see are violin plots of the different variables as they relate to, for example, here's the age at the event of being diagnosed with COVID. In the peach color is the original data and the distribution of age. In the teal color, it is the synthetic data derivative and the distribution of age. So as you look at these violin plots, you can tell how closely the synthetic data derivative approximates the real data. And then the last thing that I want to be able to show you here as I scroll down is a correlation comparison. So this graph indicates Spearman's correlation between all pairs of variables, comparing the correlations that are there in the original data set or the real data with the correlation of each pair in the synthetic data derivative. So if they fall along that diagonal line, it means that there's a perfect correlation between the correlations of the real data and the synthetic data derivative. So from this graph, you can see where the outliers are in terms of where the correlations were not exactly perfect and where your subsequent analyses may break down in the process. So with that, I would welcome any other questions that you may have for me at this time.
Randy, I don't think people were able to see the spreadsheet that you showed earlier.
Okay, I'm sorry about that. I was afraid of that. Here we go. All right. So I was showing you that at the top of this spreadsheet, you can see the column headers, and these are the variables that we requested along the way. As you scroll around, you can see that these patients look and feel like real data, and so they can be analyzed accordingly. And each synthetic data derivative comes out as this flat file with the rows of observations corresponding with a synthetic patient.
Thanks, Randy. So there's a question maybe from John Busett you might want to answer. This is asking whether the integrity of the synthetic data is enough to allow publication, or is it more for exploration?
Our experience is that it can be used for both. So what's really great about the flexibility of this particular platform is you can explore, as I did here with you in about 10 or 15 minutes, what the potential associations between variables may be. So you can get an answer very quickly from these data, which some people may view as preliminary, and then they could go to their IRB and get access to the original data if they wanted to explore it further. But our investigation into those 3 use cases that I included in the PowerPoint for today indicate that we get the same answer across those 3 use cases, whether we're using the real data or the synthetic data derivative. So from my point of view, these data are robust enough for publication. But the purpose of this synthetic data validation work group is to make sure that we put these data through their paces and make sure that indeed that is the case, and we can't necessarily break down this, this process that I've presented to you today.
Another question, does synthetic data replicate the missingness in the original data? And could you use it to build predictive models? Does it replicate from the original data?
Yes, so it does reflect the underlying source data in that these empty cells that you see in front of you are missing in the source data. So therefore they're missing in the synthetic data derivative. You can use these data for building predictive models, and you'll see an example of that in the slides. In use case 1, we did that for trauma severity. And in use case 2, we actually did that testing and validation separately using the real data for testing and validation first, and then the synthetic data for building the model and then testing it on real data in the second example. So you can not only build predictive models, but also build and validate models on real versus synthetic data, respectively.
Here's another question about whether MDClone can handle longitudinal and temporal data, and does it preserve that in the synthetic cohort?
Thank you for that question. And Justin, thank you for reading the questions for me from the chat. So absolutely. So MDClone's data in the data lake are stored in a longitudinal story of the patient. So each patient has a time and date stamp for everything that's done, whether it's prescription of a medication to a diagnosis, to a hospital encounter, and so on and so forth. So the longitudinal nature is indeed preserved, and I will show you here, for example, these death dates shown here in this grayed out column, this column 1, show the days that have elapsed since the COVID positive diagnosis. So that longitudinal nature of the data is maintained in this derivative.
Great, thanks, Randy. Let's see. Looking at other questions, does the algorithm produce the exact same number of patients' data as fit the cohort definition in the original data?
That's a great question. So the synthetic data derivative does not correspond one-to-one with the number of patients in the real cohort. And that is because, as I alluded to before, a few patients are trimmed, if you will, from the edges if they have a string of unique data elements that cannot be replicated in the synthetic data derivative. In other words, if their privacy would be exposed in the synthetic data derivative, then they aren't derived as a synthetic patient. So there's often the same number, but never more than what's in the original cohort.
I'm sure there's some statistical properties underlying that. I think we have time for one last question. Can you generate synthetic data with multiple outcomes?
So you can generate synthetic data with any of the variables that you wish to include in your analysis. So you can specify multiple outcome variables in that list of output variables, where I showed you laboratory values and medications and comorbidities and death date and so forth. You can specify multiple outcome variables in that single query in order to get this flat file. So the file that's in front of you, for example, we could specify D-dimer as an outcome in an analysis. We could specify that the patient had fever as an outcome in the analysis by using this particular synthetic data derivative. Or you can run separate queries with different outcomes in mind and different predictive variables in mind.
Okay, and that takes us to the top of the hour. So thank you very much, Randy, for that great demo and presentation. And reminder that this is a work stream. This is part of a work stream that's being led by Philip Payne. If you're interested in learning more about the synthetic data effort and want to participate, I encourage you to sign up for that work stream. So with that, conclude the call. Thank you, everyone, and have a nice week.
Thanks.